Welcome back to my channel, and you know that on this video we are going to learn how to decompose radical rational expression. Okay, and we are going to decompose them into partial fraction. So in my videos, you can see, if you've been watching my video, you will see where I explained how we are going to do this, but I'm going to make a little bit of addition compared to what we've been doing before. So this, we have a quadratic here that is irreplicable, so we cannot replicate this. If you say let us expand this denominator, so that means we are going to get something like imaginary number, and we don't want that here. What we just simply want to do is to break this into fractions. So, and if you want to do that, you will now say that 3x squared plus 8x plus 6 over x plus 2, x plus 1, that's s squared plus 1, equals a for this first factor. So we have x plus 2. Then I have plus. We have what? We have x to the power of 2. Because of that, our constant will be bx plus c over x squared plus 1. Okay? That is what this is going to look like. Let me use this marker. So what are we going to do? We have to multiply both sides by the common denominators. Okay? And that is x plus 2, x squared plus 1. Here we also have x plus 2, then s squared plus 1. Okay? So, of course, if we use this to multiply the numerator, this is going to cancel out this. So we have 3x squared plus 8x plus 6 will now be equivalent to, if we use this to multiply this. So what we are going to have is a x squared plus 1, because this we cancel the x plus 2, right? So now plus b, x plus c. Okay, so this will be multiplying, of course, when we multiply this through. So this we cancel this, so we'll be left with x plus 2. Okay, so now we've been able to, simplify it a bit. So we need to find the value of all these constants, a, b, and c. Okay, so for a, we can equate this to be 0. We can make these terms, we can make them to be 0. How can we do that? We have x plus 2. We can say x plus 2. Let's equate it to be 0. So we say x equals to negative 2. So we can say let x be equals to negative 2 for the entire equation. So we have 3 negative 2 squared plus 8 negative 2 plus 6 will now be equals to a by negative 2 squared plus 1, right? Plus b multiplied by negative 2 plus c, then we have negative 2 plus 2. All right. So here we have 4 times 2. 4 times 3 is going to give you 12. So 12, sorry. We now have 8 multiplied by negative 2 will give us negative 16. Then plus 6 equals, so we have a multiplied by, this is 4. 4 plus 1 is 5. So we say 5a. All right. So here we have negative 2 plus 2 is 0. So 0 multiplied by everything here is going to be 0. So this side is systematically cut off. So we have negative 2, negative 12 minus 16 is going to give us negative 4. Negative 4 plus 6 is going to give us 2 equals 5a. So divide both sides by 5, divide both sides by 5. So 2 over 5 equals a. So that is the value for a. Now, let's find the value for b. So now, you can see that b and c, when we multiply them, is going to be very, very difficult for you to get the value of b and c just the same way we did a. So what we are going to try to do is try to make this to look like system of equation. So what do I mean? So we can distribute this out. So let's do it from here. So we can say 3x squared plus 8x plus 6 equals A multiplied by x squared, we have ax squared. A multiplied by 1 plus a. So we now have b multiplied by x, we have plus bx squared, and b multiplied by bx multiplied by 2, it will give you 2bx. So let's go to c. So c multiplied by x plus cx. Now c multiplied by 2 plus 2c. Okay, so we also write 3x squared plus 8x plus 6 equals, we can combine like terms. So we have x squared here, we have s squared here, and their factor is s squared. Say s squared plus a plus b. All right. So we also have x here and x here. So we can say plus x 2b plus c. Okay. Then the last part is these two constants. So we have plus 2c plus a. All right. So when you are looking at these two equations, you find that we have 3x squared. I will have x squared with this coefficient. So we can easily say that 3 equals a plus b. So you say 3 equals a plus b. Now we can also say that 8x, you can say that 8x, and we also have x here. So we can say that 8 equals 2b plus c. Then 6, which is the constant, represents this constant. So we say 6 equals 2c plus a. Okay? So you can see that this is system of equation. So what we are going to do is find each of the variables. So we have 3a. Let me write it here. 3 equals a plus b. What is the value of a that we got? We got 2 out of 5. So 3 equals 2 out of 5 plus b. So this is the same thing as 3 minus 2 out of 5 equals b. So if you do this, this is going to give you 15 minus 2 over 5 equals b. And this is going to give us 13 over 5 equals b. All right? So let's find the value of c. So for c, we can use any of these equations. So let's use the third equation. So for c, we say 6 equals 2c plus a, which is 2 out of 5. So we have 6 minus 2 out of 5 equals 2c. So this is going to give us 28 over 5 equals 2c, right? So we have to divide both sides by 2. So this will now be complex fraction. So, and this is the same thing as, when this cancels, this is the same as 28 over 5 multiplied by 1 over 2, which is equals to c. So I have 28 over 5 equals c over 10. 10, not 5, because 5 times 2 is 10. So if you simplify this, this will give you 14 over 5. So c is 14 over 5 equals c. All right? And that is your answer. So now let's represent them into this expression. So we say that, let me write it from here. We have a over x plus 2 plus b x plus c over x squared plus 1. So this is the same thing as a is 2 over 5, b is 13 over 5. Let me put them in a square. So, and c is 14 over 5. So you can see both of them, all the three constants, they have the denominator of 5. So you can say for a, we have 2 over x plus 2. Okay, so what is the 5? You write the 5 outside like this. Okay, and you now say plus b. B is what? 13x, because we have bx, plus c. C is 14. So over, both of them have 5. So 5 multiplied by s squared plus 1. And this is they are all the same thing. Okay, they are all the same. So this expression asks us to put into partial fraction. I hope this helped. Okay, in my next video we are going to talk about something a little bit more complex. So stay tuned and see you in my next video.